Thanks for joining us early. Today, I'm going to talk about Node.js Streams. I set up a demo project that I can share links to. The motivation behind this comes from the Groot data service. Some of the publisher requests pull back hundreds of thousands of rows, which ends up being, with the number of measures and dimensions and everything else that encompasses, it ends up being, when you write it to a file, it's a 128 megabyte file of JSON. So it's quite a large amount of data. And when those requests are made, and our traditional stack of making the request using Knex, and getting the entire data set back in memory, serializing that out to the client, we just see a huge memory spike. So that's what I'm gonna go ahead and demo here today. The memory spike, on a couple of steps on how we're planning to reduce it. So I'll share my screen here. All right, so this is the demo project I've set up, and I'll send out links if anybody's interested. It's a PG query stream demo. And so I'm going to go through this. I'm also going to show you the Node.js documentation. So streams are built into Node.js. I think they've been, they've been with it for forever, but there's been a lot of additions and support added since version 10. So it's very mature and very robust. Also very well thoroughly documented, I should say. There's a lot of documentation, and that's probably one of the trickiest things to go through, and it's kind of it's difficult to traverse. And I think that this article, which actually ends up being a really good article, summed it up very, very well. Streams are hard, but they're not too hard. It's just there's a lot of moving parts. And it's the Node.js documentation is scattered. It's a big feature. It's just there's a lot to kind of go through, really a lot to understand about streams. But once you start to use them, you're going to see how powerful. And in actuality, everyone's already using them because all of the request file streams, everything else, they're already using streams. Just we're not necessarily using it end to end and streaming it to our API endpoint. So that's what we're going to be going through today. So streams themselves, you can go into the documentation for Node.js. Again, it's huge. There's a lot here. But the important thing to get from here, if I can find out, let me go back up to the top, is types of streams. So there are several main types of streams. You have writable streams, readable streams, duplex, and transform. So duplex and transforms, I think transform is actually a duplex, and duplex is simply inherited or extending from both readable and writable. So at the core, there's two types of streams. There's readable and writable. But then, of course, then there's duplex, which becomes a readable and writable. And then transform extends off of duplex, and I actually have an example, and I'll show you how that's set up. As far as what these are, you probably used file streams for readable streams or writable streams. When you're working with Express or just HTTP and Node.js in general, your requests are going to be the readable streams, and your response is going to be the writable streams. So you're already working with those. And then duplex, what we were going to set up with our stream here with the database is actually going to be a duplex stream. So if you're using Knex, which a lot of us using Node.js are, you may come across this in the documentation. There's a section on streams. It's not built into Knex.js, but if you are using Postgres and you install PG query stream, that's by the same makers of the PG lib itself. So here's the PG query stream, and if I go over to the GitHub page for here, you'll notice that this is contained in the mono repo of PG. So it's by the same folks who have created Node Postgres, which a lot of people are using that. Very popular. And I believe that this is also what Express is using under the hood when it's using a Postgres client. So yeah, if you want to use streams using Knex, you just need to include as well PG query stream. When you do that, where you would normally do your Knex select or Knex raw, the last step is just to say that you want to get the stream. That's going to execute the query, but instead of returning the actual query or a promise, it's going to instead return a database stream. So that's what we're going to be using. And then from there, you can take that stream and you can pipe it to other streams, other writable streams. In our case, we want to send that ultimately to our the HTTP, the Express response. But to do so, anyone that's used Knex is familiar. Knex is going to return objects, not strings. And so when you're writing to the response, we're going to need to transform it. So we're going to set up a transform as well. The PG query stream documentation is very light. In fact, in my opinion, it's lacking because while it's mentioned in the Knex on how to use it here, it's not mentioned how to use this with Knex, which is probably where a lot of people coming from Node.js are coming at this. Here, they're just mentioning the PG client and how to use this with PG directly. This certainly works, and you can do this, but if you're already using Knex, then you're probably not going to go this route and set up a separate PG connection if you already set it up with Knex. So just pointing that out. That's that. Okay, so let me go over to the project here. And it's a simple project, simple demo project here. I've got one demo service and one Postgres client. I'll start by explaining what I've done. Set up with a Postgres here, using Postgres 13 Alpine, giving it a container name. This just sets the wall size only because I'll show you the SQL script we're going to run, just helps with that. The environment to set up the user and password and database that we're going to use, a volume, and then my init SQL, of course, exposing the port and a volume for the PG data. The init SQL, we're going to create one table. We'll call it Streamy, and it has an ID and name, being the text field here. And then we're going to insert into Streamy. We're going to generate a series of 10 million rows. So we're going to insert 10 million rows into our table here. And I just wanted to give it more data, so I gave it an ID and a name column, doing an LPAD on this to pad it with zeros, so it's all sequential there. So 10 million rows, that's what we have got in our database. Then I've got the demo service itself here, and been setting this up. We'll call it demo, just the debug, and then just setting some volume, so for debugging purposes. So the service itself is pretty basic. Got a Docker file here, not much to it. Just copying in the code, installing what we need. I've got an index file. This is using Express, and some functions up in there. I'll explain those later. The key to this is I've got several endpoints here. One is going to be raw, and what this is doing here is this is going to get our data straight from the database and send it back to the response. This is our typical. This is how we normally would write our, all of our API requests, right? We get the data and we send it to the response. This next one here is a half stream, and what this is doing is this is again getting the data from the database. So it's not streaming from the database. This one is again going to get it from the database, but in this case we're going to stream it now to our response, and I'll show you what's going on in there. This one here is going to be our full stream, and with this we can set a few things. We can set our batch sizes and what is called a high watermark. So with batch size and high watermark, batch size is going to be how many requests you get in each chunk from the database, and depending on the data that you're working with and how much I don't know how much you're returning in general, you might want to play with this number. So in my case, a sweet spot seems somewhere between probably closer to 5,000. I just set some defaults here to 1,000, and then a high watermark is going to be how much how much we're actually, sorry, my wife's getting stuff out of a drawer here while we're talking. High watermark is going to be how much is going to be allowed in the buffer. And it's not a strict limit, but it's once it goes above the high watermark, then the library will stop pulling more data. So it's not that the high watermark is the actual physical limit. So like if I put 999, right, or whatever, something like that, it would actually go above that, and then it would stop. So, are you almost done? Thank you. All right. So the high watermark and then the DB stream. Now this is where we're going to actually make the request here. We're going to, again, now this is using the PG query stream. We're getting back a stream. And so then I'm now passing our response and our stream to this function here. So that's what I'm going to show you what's going on in here. But before I do that, let me go ahead and bring this up. And we'll show you what some of these do. So Docker compose up. I've already run the database volume, so we don't have to go through and create those 10 million rows. It doesn't take too long, but it's still about 20 or so seconds. So bring this up, attaching. It's taking longer than expected here. Oh, I guess I already have it up. That's why. Okay, so I had it up already. Yeah, that's fine, whatever. Okay. So I've got some really poor man's documentation. Just gives me some links. There's just a test function there, so I can just see the database version. So this first one, raw, right? This is where it's getting the data straight from the database and right into the response. So it's doing it kind of what it's expected. These endpoints are set up so that I can request however many rows back I want. So I can request 1 row back. I can request 0 rows back, et cetera, or 100 or whatever we want to request back. And it's going to give the data back. The half stream here, this is now where it's getting the data into the memory there, and then it's going to stream it for the serialization step. And then the last one is the full stream. And I guess something broke. Wouldn't be a live demo, right? Stream on air. I don't know what happened there. Couldn't retrieve data from the client. It is very possible I broke something in my latest changes here. Yeah, I think I did just make some recent changes in the last function that I was going to show off here. So let's start by looking through this file, and maybe it'll come to me while I'm looking at it. So this is the function that we're calling from the API calls, passing in the out stream and in stream, and then data is optional in this case. And this was just quickly set up so that I can demo the two purposes of like the half stream and the full stream. So the full stream is going to pass in these two items, and the half stream is going to pass in the out stream being the response, and data being what's sent in. So I just have a check here to say, if the stream is non-existent, we're actually going to create a new stream, and we're going to set it to just a readable stream. Object mode is true. Again, we get objects back from Knex querying the database, so we need to specify our stream as object mode. By default, readable streams and writable streams are also by default both string mode, so string or binary buffer. So you have to explicitly set this to object mode, otherwise it won't work. And then I've gone through and I've just attached some on events, and apparently this is where instream.on is not a function. Apparently it doesn't like this now. That was entirely working. I don't know when that broke. So let's try this again. Just comment that out. I'll have to look at that again. Instream.pipe is not a function. Wow, something just completely broke here now. All right, so let me keep going, looking at the rest of this. And so you got the in-stream pipe. So this is the magic line right here. This is going to take our in-stream. This is going to be either the database stream or what we just defined up here as being our readable stream. This is the data that's going to be coming in. We're going to pipe this first to our transform, and then ultimately we're going to pipe it to our outstream, which we're passing our Knex response there. Now this get transform is going to return. This is also part of stream. Remember, if you recall, this is a readable, writable stream. So transform. In fact, you can click into these and you can see transform extends from duplex. You can click into the duplex and see it extends from readable and implements writable. So that's how that works. So the transform, and again, like I mentioned, you have to specify that it's going to be an object mode. So this one's a writable object mode, true. And we're going to implement two functions in here. And this is going to be our serializer. Now, if I go back over to the documentation here, specifically for PG query stream, you'll notice that they've got this in their documentation, JSON stream. So this is what they're using. They're using string.pipe, piping this to JSON stream.stringify, and then that pipes it out to standard out. This does work. And you can use this. It's a little bit tricky. This is an older library. If you're wondering, like, you don't really see too many case-sensitive node packages. That's because they're not allowed anymore. But JSON Stream was an older one, and it was allowed at the time. And so this is kind of a package. In fact, if I go to npm JSON Stream, you can check this guy out. Very popular still, 6 million weekly downloads. But you'll notice that it's using JSON parse and through. So it's not, and through itself is not using the built-in Node.js stream. So this was a bypass for getting around some of the support that Node.js had for or exposed for developers to use the streams. So yeah, this transform no longer requires the use of that. This is just now using some stringify logic here. So we're keeping track to say if we don't have a comma, we're going to open our bracket. We're going to stringify these functions are called every single time data is called. It's the one object record from the database. Now again, we're calling when we're using PG query stream. It's using I don't know if I highlighted that. It's using a cursor to pull the records. So when you specify your batch, it's going to pull the batch size, whatever. If you say 5,000 or 1,000, it's going to pull that batch size. But when the data is actually transformed, it's transformed record by record. So each one of these data objects is one object. And so we're just going to wrap those in our brackets here. The final call here is if we didn't actually open anything, and I demoed that with well, I guess I broke it right now. But if you don't have any data, then you didn't open it, and you didn't. So now you just need to make sure you set your open bracket and your close bracket. So this is just a quick serialization transform to serialize it to the JSON from objects while keeping it as a stream, and then piping that out to the outstream. Now this is the trick for the half stream, is we're going to take our data in here, and if we have data, we're going to pipe it, push it into our stream. And so we up here, remember we didn't, for the half stream, we're getting all the data, but then we want to use the serialize aspect. So if I can, I'll demo this and show you how that works and how this actually gets you some memory buffer and so it doesn't spike as high. And then lastly, you need to push null to signal the end of a stream. So that's what that is there. There we go. Okay, good. All right, we can proceed with the demo. Don't have much time left, but we'll do this quick. Okay, so let me jump over here, and I've got this running right now, so we can just attach this here just to see the logs. I'm going to run our stats on our demo project in this window here, so you can see the memory Right now we're, of course, you can't click on it. Let's try that again. Hovering around 50 meg, that's its baseline, so that's good. Here, I'm going to monitor this directory. Let's see, let me do an RM. Well, let me come back over here and just clean it out, because I want to keep the git keep in there, but we'll start fresh. Okay. I guess there's some large files. All right, well, that's going. Just watch this directory here. Okay, it's already cleaned. Okay. Oh, there's no watch command on Mac. So this is a poor man's watch command. While true, do clear ls.lh, the temp directory, sleep one done. So every 1 second, it's just going to keep on running the ls on there. So this one's running. This is just the logs. This is watching the temp directory where I'm going to write some output files, and this is watching the memory. So now here we can go ahead and execute some commands, and let's go ahead and I have them in my README here. So first one is I'm going to take a look at some of the half streams here. I'll just start off with a small one. This is going to request apparently, I don't know, I have it 10,000 in one spot and 1,000 in another. All right, we're going to do 10,000 records. And so what you can see here is here's this half stream. It already finished. That was just too fast because you know what, I think by default I have the batch size as 1,000 and the high watermark is as whatever it is, 10,000. It requested that pretty quick and it's wrote it out real fast. So that happened real quick. Let's make this bigger. Let's go ahead and jump to 1 million. So we're going to select 1 million rows. That's going to get it fully into memory, but then it's going to stream it as a buffer to the response, which here we're going to be writing it to file, right? We're piping it to file. So that's going to happen in all through the buffers. So when we write that, here's the file here, and you can see it's growing in size, 14 meg, 20 meg, and up here you can see our memory going up to 250, and then it stopped. It's already done. So that's where that got to. Now I'm not going to do the full 10 million. That really hogs my memory and does a lot. So let's do 3 million as like a happy medium, just to see it a little bit longer, to see how high we can get this memory. So you can see here it's already going up almost 600 meg. It got up to, but 500. But you can see, here's the important aspect. You can see it going up and down, and that's that streaming buffer aspect. So that file is still being written here, but you're noticing that this memory is going up and down instead of just still going up and up and up and up before it finally flushes and dumps the entirety out to the client. And there, that one's finished. Now, this is all the half stream. Let me do one more with the. I didn't show you the original, the raw. Let's do 1 million with the raw, just to see where that gets up to. This is to show you how high the memory actually gets. So there it was. It shot up to almost 750 and then dropped. It was really fast though. Let's do the 3 million. And I realize I'm not changing the full names here, but that's okay. So here's the 3 million. I'd expect this to easily get over a gig versus when we did this with the half stream, it was around 500 meg. So there you go. Easily got up to 1,200. So like 1.2 gig. Lastly, we're going to do the full stream. And we'll go ahead and do the full 3 million. Now this memory is kind of staying there for a little while. Let me go ahead and flush this out so we start back at square one. So we can actually see where this full stream, how high this actually gets. So I could wait. It would ultimately, Node.js would do, its garbage collection and free up that memory. But this just forced it. So we're going to do our full stream now, 3 million. Before, remember, our half stream, was around 600 meg, and the raw was 1.2 gig. So here we got this. Oh. Did I hit enter? I did. Okay, so it should be running, and I think I hit it. I don't know. Oh, I hit a breakpoint. How did I hit a breakpoint? My bad. Oh, I had that breakpoint set. Okay, so there you go. Full stream is writing now. This is what's important, right? It's already writing. So, if these are big, large queries, you would normally be waiting for it to retrieve all that data. We're retrieving 3 million rows. And look at this memory, 100 meg, 114. It's like whatever I set my high watermark to, that's kind of where it's going to have its buffer line. So I could do those batch sizes higher. I could set the high watermark higher. The batch sizes might help speed it up. The high watermark might also help speed it up. So anyway, that completed though. And we wrote out a 113 meg file there. And our memory stayed around 100 and something meg. So it's really cool, really low. Now, real quick, some of the challenges with streaming are error handling. And so one thing I did in here, I just want to show this real fast because, two things actually. So I glossed over this at the beginning, the writing streaming headers. You have to change your heading when you're doing streaming. Your content type is, you specify your content type, but you need to specify your transferred encoding as chunked. I don't think this is required, but the chunked is what's important here. Also, you'll notice that I'm going to be setting the status as 200. So this assumes one of the challenges with streaming is you have to specify this head up front and set your transfer encoding to chunked. And by doing that, you have to set the status. So your status is already going to be whatever it is. If you have a database error, it's too late. You've already set your headers. And so this is one of the challenges that we're still, I'm still looking at and trying to figure out how to address. And you also might have it where, so you also might have it where something might error out. So what I've done here is I've done this ID and divided by ID minus 10. So I'm going to select 10 records. And obviously what's going to happen on that 10th record is going to be 10 minus 10. You can't divide by 0, right? So we're going to hit a database error. And that's something that could potentially happen in group, for example. There's a lot of calculations and there's potential. We've tried to put in handling for everything that we can. But again, the other cases, it might still come up where you might have an error. And so you might be selecting 1 million rows, but then suddenly in some point, one of those rows throws an error because of the calculations. So this is going to be an example of that. And so let's see if I have that. Okay, so this was full stream. And I just want to select 10 rows. Actually, I don't even have to do this in the curl, so it doesn't matter, but I'll do this here anyway. All right, so let's do this to JQ, and we'll see what happens there. Okay, so there's a good example. I ran this, it threw an error. I got a 200 back. I'm not showing that in this example, but this returned a 200, but this returned the error. Now, this is because I have the batch size at such a large number. Now watch what happens when I set the batch size to 1. We're actually going to execute every single row before we get to that 10th row that actually threw the error. And this is that example where you might have, if you're selecting 1 million rows and suddenly at 600,000 or something like that, one of the rows throws an error. This is how we can manifest that error into the results is just returning an error as one of the records. Because again, it's too late. We've already been streaming data. We've already been going and going and going, and now we hit an error, right? So this is how I'm trying to look at the handling. If somebody has ideas here for how to improve this even further, or if they've had experience with this, I'm more than welcome to, or please reach out to me and let me know. But let's see other things. You could, let's say I misspelled a column. This is going to throw an error right away. But again, this is already making a request to the database. The response headers are already sent because now we got a stream, and this stream shows that there's an error. So this is one of those challenges. We're going to have to figure out how to work with the consumers to do this full streaming here. Now, yeah, that gives you the header. So you can see here, there's the header. It's a response of 200, and then the important transfer encoding and chunked. But that's it. That's my Whirlwind demo. I've got this project. I pushed this as a demo project up to GitHub to kind of play with it. I'll send this around. Anybody can pull this, check it out. And I guess I might need to double check that it's working as is. Maybe I pushed something wrong there, but feel free to play with it, check it out. It's pretty, I try to keep the demo as basic as possible while serving its purpose. So any other questions?
That was awesome. That's really cool. It's kind of edge of the seat too, because he, ran into the problem. He debugged on the fly, and then we got the full-on demo. That was awesome. More drama.
Drama, yeah, live demo drama.
It goes with the background.
Yeah.
Steve McQueen.
No.
That's Blues Brothers. Blues Brothers, buddies.
No. Blues Brothers.
Yeah.
Yeah.
I'm sticking to Steve McQueen. Sorry. It's my West Coast attitude.
As someone pointed out the other day, it was this was the point in the movie with the those effing Illinois Nazis or whatever it was, right?
Yep. I love you.
I got to jump. That was an awesome job. Thanks so much.
Cool. Yeah. No problem. All right. Thanks, everyone. Have a good rest of your
Ryan.
Friday and a good weekend.
Bye-bye.
Good weekend.
Thanks.